Here we go. I'm showing you a new method of calculation. It's called dimensional analysis. This is very commonly used in chemistry, and so it's a method you want to learn how to do. Let's start with a traditional problem. Let's imagine you're given random number 37 grams of aluminum, and you're asked to find the volume. So this should look to you like a normal chemistry type problem. Volume is measured typically in cubic centimeters. And we'll do this problem two ways, one with the traditional proportion and one with the new method using dimensional analysis. All right, traditional proportion, you start with your given 37 grams aluminum, and you're trying to find a different unit of measurement, cubic centimeters. To do that, you need a ratio, a known ratio between grams and cubic centimeters. I'm hoping that looks to you like density. This problem involves density, so you'll look on your periodic table for the density of aluminum. Try to find that before I show you. So this is what it should look like on your paper. Periodic table tells you 2.70 grams is 1 cubic centimeter of aluminum. That's the density. To solve this, you typically cross multiply. Go ahead and solve it before I show you. All right, so this is what your answer should look like. This is what your algebra should look like. And there's your answer. Now, the same problem can be done a different way using what's called dimensional analysis. Dimensions refer to the labels on the numbers, things like grams, moles, cubic centimeters. That's what is meant by dimensions. Dimensional analysis has a particular look to it. You start with some given value, multiply by what's called a conversion factor that has something on the top and something on the bottom. So it's a ratio. This conversion factor is always a ratio. These will have numbers as well as labels. And then you get your answer. So it has a different look than a proportion. It's one line straight across. Let's do this particular problem with dimensional analysis. The given is 37 grams of aluminum. The conversion factor will have something on the top, something on the bottom. The answer, in this case, will be in cubic centimeters. You can see that was stated in the very beginning. Given, grams, ending point, cubic centimeters. Conversion factor will have those two units in it. It will, in fact, be the density. This density is the conversion factor. But what's important is to decide what goes on the top, what goes on the bottom. What's in the answer is cubic centimeters. That goes on the top here. And these grams that we start with do not appear in the final answer, so they need to cancel. So if I put grams on the bottom here, I'm hoping it makes sense to you that grams will cancel grams. This is the conversion factor without numbers. I need to tell the truth. The truth is, according to density, 1 cubic centimeter is 2.70 grams. So you'll notice if you look at this red conversion factor that it is the upside down version of the way I wrote the density in the blue version. The reason I know it's upside down, grams must cancel. Cubic centimeters must survive. To do the actual calculation, whenever you have a fraction, you multiply by what's on the top, divide by what's on the bottom. Multiply by what's on the top. 37 times 1. Divide by what's on the bottom. 2.70. What you should see here is that I'm doing the same kind of math that I had in my proportion. It's going to be 37 divided by 2.70, which is going to get me the same answer. It has to get the same answer. There's only one right answer to the question. But it does so in a way that looks significantly different. So 13.7 cubic centimeters is the answer to the problem. Now what I'm putting in a green box here, what I'm circling with my big green rectangle, that is dimensional analysis. A given times a conversion factor leading to an answer. It's a different way of doing calculations. You may find that you really like this method. So learn how to do it, and then maybe it'll be your method for the rest of the year to do all these chemistry calculations. I'm now doing a second example of dimensional analysis. This one you can see the given will be in moles. So here, random number, 1.24 moles of calcium chloride. And let's say the destination this time is to find the number of grams. So you've been doing problems like this with proportions, and we'll do this one also with the proportion, but then I'll show you how to do it with dimensional analysis. I'm hoping you see that the tool this time, the conversion factor, is going to be molar mass. That gets you a relationship between moles and grams. All right, traditional proportion, 1.24 moles, CaCl2, clearly labeled. How many grams is that? Need a defined ratio, which is the molar mass, 1 mole. So you'd add up the parts here. There's calcium and 2 chlorines. Calcium, let me do this note in the margin here, Ca equals 40, and Cl equals 35 from the periodic table. But we multiply by 2, so that's 70. So the total is 110 grams per mole. All right, so that's my conversion factor. That's my ratio. 1 mole is 110 grams. So I'm hoping that looks perfectly normal to you. Go ahead and get an answer and then check against my answer. So here you can see the cross multiplication is very simple. And the answer is simply the multiplication. So the answer is 136. The label is grams. If we want to be more specific, grams of calcium chloride. Done. Let's now do the same problem with dimensional analysis. All right, dimensional analysis always looks the same. Start with your given, multiply by the conversion factor, which has something on the top and something on the bottom, and then you get your answer. So this is the setup. It always looks the same. Label every number. 1.24 moles calcium chloride times some conversion factor equals grams as an answer. All right, conversion factor is going to be the molar mass. Same thing we saw before. Question is what goes on the top, what goes on the bottom. Grams is the answer. Therefore, grams should be on top here of the conversion factor. And moles, we want moles to cancel. So moles should be on the bottom. I'm hoping this looks to you like moles, cancel moles, and then we're left with grams as the unit of measurement for the answer. The truth is 110 grams is 1 mole of calcium chloride. Therefore, this is the correct setup. The mathematics is multiply by what's on the top. Again, you wouldn't normally write this, but I'm writing it for you to see. Multiply by what's on top. Divide by what's on the bottom. And you would see that the answer is exactly the same kind of math we did before. 136 grams CaCl2. So this is what dimensional analysis looks like. It is a method that I want you to learn how to use. Your textbook uses this. Many chemistry teachers, this is the only method they teach. They don't teach you proportions. So it's something you want to be able to do, And then you can decide, after you've learned it, whether this is the way you'll do all your problems or some of your problems. The next thing to do is to look at assignment 54, which is dimensional analysis 1, and see whether you can apply this method to the problems there.